So let's look at question number 1 from the question I asked you to try in the group. So there we have, so on a potentiometer, we have this question, 100 ohm, this is 20 ohm, and it is connected to a 12-volt battery. So this is connected to a 12-volt battery. Now, here we have a voltmeter and a 2-volt battery. So we have to find the reading of the voltmeter. So we know when this is ideal, current through this is 0. Current through the voltmeter is 0. Therefore, there is no current into this junction. So you can consider this as a potential divider. Here we have a 12 volt of increase, and here using the potential divider, we know that it is 1:5. So 1/6. Here you have a 2 volt of drop. If I mark, if I consider, I can consider any point as earth. So I'll consider this point to be grounded. If this point is grounded, here the voltage has to be -2 volt. And here we have a battery. So this battery will increase the potential by 2 volt. So here it's 0 and here it's 2 volt. So what is the difference? The difference in the potential is 4 volt. Therefore, the voltmeter reading is 4 volt. Amna got it, and Shahama, have you got this answer? Let's look at question number 3. In question number 3, we have 15 ohm and 5 ohm, a voltmeter, 9 volt battery, and a 12 volt battery. So here the potential will increase by 12. Using the potential divider, it is 1:3. So 1/4. 1/4 of 12 is 3 volt. Here we have a 3 volt drop. And here this battery will increase by 9 volt. As I mentioned, if you want to find the reading across a voltmeter, we have to find the potential on either sides, right? So let's consider this place to be ground. So if this is ground, the voltage here is -3 volt. The voltage over here is -9 volt. Then only it increases by 9 and this becomes 0. So what is the difference here? The voltmeter reading is the difference between them, and the difference is 6 volts, right? Got this answer? Okay, so what's the next question? Question number 13. So in question number 13, we have a potential divider circuit, right? So we have a 10-volt battery and a variable resistor. Here we have a resistor and a key. So we have to find what is Vx. This is earth. So this is 10 volt. Now, here, if this is earth and the potential will increase in this direction, if you move along this direction, you are going against the arrow. Therefore, here you have a drop. This is minus 10 volt. So, this is A, B. So, if we move the key, here the voltage is 0. The voltage at A is 0. Between A and B, you only have negative voltage. Okay, you have only negative voltage. Now look in which direction they have given Vx. The Vx, the arrow is pointing in the upward direction. Therefore, you have to get the difference between these 2 points. Okay, you have to deduct this voltage V from this. So V is always 0. So if we plot the graph for Vx versus x, initially, where is it starting from? At A, it is 0. And when you go up, what about the potential? It is becoming negative. So it goes to negative 10 when it reaches B. Is it clear? Rahama, did you get the idea? If this one was in the opposite direction, just like this, then what can you tell about Vx? That means you have to deduct this value from this value. So it will be positive. This is negative. But if the question was just like this, I will say Vy, it will be positive. Is the reason clear? Why? I will clear with the reason why this happens. Amna, are you clear about this arrowhead? So keep in mind, okay? So you will deduct the potential from your arrowhead direction to the tail of the arrow, okay? So that is the difference here, the potential difference. And question number 14, that is not that hard. What is the answer? You can just straight away look and tell the answer. There is no current flow in the circuit. Therefore, A, B, C, D, they should have the same potential, right? It's just like this. So this is ground. EMF is given as V naught. A, B, C, D, E, and F. So I'll tell this switch is K. K is open. If K is open, then how will be the graph? F and E will have zero potential because it is earth, but here, due to this battery, the voltage or the potential increases by V naught. Therefore, A, B, C, D, all of them have potential V naught. And F and E have zero potential. A, B, C, and D, E, and F. Okay. Let's say K is closed. If K is closed, now the case is slightly different. If this is closed, now we have a current flowing. Therefore, across BC, we will have a potential drop. So at E and F, at A, we have V naught potential. At A, we have V naught potential. And from B to C, the potential should drop to zero. And afterwards, it's zero. So this is A. Over here, it's B. And over here, it's C. Next, D, E, and F. Both of you clear with these two graphs? Okay. So yesterday we were discussing about Kirchhoff laws, right? On Tuesday, we were discussing about Kirchhoff law. So Kirchhoff's law, we had two laws. First one, we call the KCL, where we equate the current. We equate the current entering the junction to the current leaving the junction. Okay, so that is the Kirchhoff current law. We in short call it as KCL. Okay, so the second law, we call it as the KVL. It says the Kirchhoff voltage law. So here it says the sum of potential increase. So here these two are potential increase. Sum of potential increase is equal to the sum of potential drop. So here we have a drop across the resistor. So if we had another drop, let's say we have a load over here and the drop across it is V1, then we will have to add that V1 also. So sum of the potential rise is equal to the sum of potential drop. That is KVL, and equating the current is KCL. So these two are the laws, Kirchhoff's laws. So we were discussing a few examples, right? In the last session, we were discussing a few examples. Let's continue. Can you remember the example number? We discussed two examples. Two examples, right? So example 3. We have two batteries. We have two batteries. Voltage is 6 volts and it has an internal resistance of 0.5 ohm. And the second battery is of EMF 2 volt and has a internal resistance of 0.3 ohm. And two resistors are connected on either sides as shown. This is 1 ohm and the resistor on the other side is 0.2 ohm. Now, the question is to find the current I. So the question is find the current I and the terminal voltage across the battery, across each batteries. Okay. Now here, have you noted the question? I'm not done. So here we are going to use Kirchhoff voltage law. So in Kirchhoff voltage law, let's consider this loop. When we consider this loop, what is the total EMF? Here we have an rise. The voltage will drop across this resistor because the current is going in this direction, and here it will drop in this direction. Okay. So what is the sum of the EMF? Sum of EMF is, let's travel in one direction. I'll travel in clockwise direction. Okay. So I am traveling in clockwise direction. When I travel in clockwise direction, here we have an increase, 6 volt. But this battery is in the opposite direction. Therefore, it is a drop. So we have to write 6 minus 2. That is equal. Now let's equate the drops across resistors. So here, what is the drop? Current is I. The resistance is 1 ohm. Therefore, I into 1 plus here I, the same current, I into 0.2, I into 0.2. So 4 is equal 1.2 I is equal 1/3. Over 1.2. So this is equal 10 by 3. 3.33 amperes. Amna and Shahama, is it clear how I got this equation? What I have done is I have got the sum of the EMF. But here, when the batteries are in the opposite sense, when you go along this loop, when you get batteries in the same sense, that means the arrows should be in the same sense. You add them. If they are in the opposite sense, you deduct them. So here we have to deduct. Clear? Are you all clear with the left hand side of the equation and then the right hand side of the equation? Clear? Shahama? Okay, then let's try another example. Example 4. Here we have two resistors. (16 ohm and 14 ohm). And then we have two batteries, 10 volt and 25 volt. The question is to find what is the potential difference between these 2 points, V naught. Find V naught. To find V naught, the first thing is to find the current in the circuit. We have to find the current in the circuit. So here, first analyze and tell me, in this loop, are you going to have a current in the clockwise sense or in the anti-clockwise sense? What is the sense of the current? Is it clockwise or anti-clockwise? So here, if you check the EMF, this is 25, this is 10. So which one is more powerful? 25 is powerful. Therefore, it will send current in this sense. Okay, so your current is going to be in the anti-clockwise sense. Okay, Amna. So can you put an equation? Can you put an equation and find what is I? Okay. So Shahama, can you find the current I? Amna, check here. Here, which one is greater, 25 or 10? Between these two batteries, which one is having more power to send current? 25. So 25 will try to send current in anti-clockwise sense, and the 10 volt will try to send current in the clockwise sense. Which one is more powerful? 25. So eventually that will win. So the current will be flowing in the clockwise sense. Amna, did you get it? So now can you find current I? Amna, have you got 0.5? Now we have to find V naught. Now we have to find V naught. To find V naught, let's use that potential, different potential drop using those arrows. So here we will have a potential increase. So I'll mark the arrow in this direction. Here, across this resistor, we will have a potential drop. The current is flowing in this direction, right? So it is in the opposite direction. Then only there will be a potential drop, right? So here, to find out what is V naught, I must know what is the drop here. I must know what is V. How to find V? V is equal IR. So I is 0.5, R is 14. So that is 7 volt of drop. So V naught is equal 25 plus 25 minus 7, because from here I am starting from here. Here we have an increase in voltage by 25. Here we have a drop because the arrow is in the opposite direction. So V naught is equal to 18 volt. Is it clear, both of you? Amna, okay? Have you noted? Okay, quickly note. Tahama, example 5. Under Kirchhoff law, try question number. Okay, so this is in your base book. Under Kirchhoff, question 6. So we have to find what is the potential difference between X and Y, right? They have asked to find Vx with respect to y. That means Vxy, which is equal to Vx minus Vy. So try to find the potential of Vx and Vy separately. When you're finding potential, it is always easy if you earth or ground one point and start. Give a try. Yes, -1. I'm not really get it. Try question number 11. So in question number 11, again we have to find the potential across xy. The first thing you have to understand is, although we have a resistor here, it is not going to work because there is no any current flow. Current cannot flow through this resistor because even if it enters, it doesn't have any place to leave. Okay, because there is no current. I is equal 0. V is equal 0, I mean delta V, potential difference is 0. Therefore, here also you have the same potential Vy and this is Vx. So actually, you have to find the potential difference across this 50 ohm resistor. So I hope you can remember how to use the KVL, Kirchhoff voltage law, and find out the current first. After that, find the potential difference across this. Okay. Make sure you mark the direction of current in this diagram, or otherwise you will get confused later. Have you all got this answer? No, you didn't get it. I didn't get your yes or no. Okay. The meeting will end and I have recorded the meeting. So it will take around 1 to 2 minutes.